The idea that we are alone in the universe is one that can keep us awake at night. But what do we actually know about the chances of there being other life out there? Are we alone? It's hard to think of our blue and green Earth as anything special. In fact, it isn't even the special one in our solar system. It is easily the most unique one. We know of none others that harbor life. For most of human history, people used to think that our world is unique with the birth of philosophy and science. We learned that Earth is among 7 other planets that orbit our sun. It took us quite a long while to realize other galaxies are out there, and that the flickering lights in the sky are other suns with whole worlds orbiting them, which could possibly host alien life. Then we didn't know of any planets beyond our solar system because we haven't detected them. So even if we thought, well, we can't be special, we didn't know. Now in the solar system there are 3 planets in the habitable zone. There's Venus, Mars, and Earth. Venus is close to the Sun, hours further away. All of those planets, though, we think had water on the surface, so they all could have been habitable in that sense, and still, we're looking for life on Mars to this day. Of course, finding life on Mars would be undoubtedly among the biggest discoveries in human history. But if there is life on Mars, most scientists think it's microbial life. The more interesting kind of life we hope to discover that would change our worldview forever is multicellular life, such as plants or animals. Luckily for us, there is a place within our solar system that might host that kind of life. Enter Jupiter's moon Europa. NASA is preparing the Europa Clipper mission, which would launch in October 2024 and will arrive in 2030. The mission is currently planned to conduct 4 years of science observations at Europa. This moon shows strong evidence of an ocean of liquid water beneath its icy crust, so it's a top candidate to explore, and hopefully we will find evidence of alien life. Going beyond our solar system, it's extremely difficult, if not impossible, with our current technology, to send space probes and find evidence of alien life, as the nearest star to our sun, Proxima Centauri, is about 4.2 light-years away. So the best method is to stay put and listen for radio signals, or direct our telescopes at the location of exoplanets and look out for biosignatures. Obviously, the most exciting type on the hierarchy of alien life is intelligence. It is estimated that with our current pace of technological growth, a civilization can colonize our whole galaxy within 10 million years. And if that is the case, where is everybody? The flip side of this is loads of planets out there, and there's been loads of time. This has got a name actually at S called the Fermi paradox, after someone called Enrico Fermi, a great Italian physicist who asked this very simple question, which is, where are they? So one possible resolution of the Fermi paradox is the great filter. It presupposes that in the development of life from the earliest stages of abiogenesis to reaching the highest levels of development on the Kardashev scale, there exists some particular barrier to development. That makes detectable extraterrestrial life exceedingly rare. This barrier to the evolution of intelligent life could be as a result of self-destruction. Meanwhile, the evolution of telescopes that can detect technosignatures could provide insights into the great filter. If planets with technosignatures are abundant, then this can increase confidence that the great filters in the past, on the other hand, finding that life is commonplace with technosignatures, are absent. Then this would increase the likelihood that the great filter lies in the future. There is another relatively recent and quite interesting hypothesis that attempts to resolve the Fermi paradox. If an extraterrestrial species becomes advanced enough to send signals we can pick up, it will likely shed its traditional biological form and become a type of machine intelligence. Within this hypothesis, it is speculated that a full digital civilization simply has no interest in colonizing the galaxy. The other interesting solution to the Fermi problem, which is popular among UFO fans, is the so-called zoo hypothesis, which entails we are being observed. Without our knowledge, there's also the depressing solution to the Fermi paradox, which is the first ones and will be extinct long before any other civilizations emerge in our galaxy. What's interesting is, when you talk to astronomers, they say that we estimate that 20 billion, potentially, Earth-like planets out there in our galaxy. Surely there must be life all over the place, right? It's a guess. Because we have unfound any anywhere, but what we know from the history of life on Earth is that life began pretty much as soon as because we have unfound any anywhere, but what we know from the history of life on Earth is that life began pretty much as soon as it could here on Earth. So we have good evidence that life was around, let us say, 3.8 billion years or so. When did complex life appear? So we have good evidence that life was around, let us say, 3.8 billion years or so. When did complex life appear? When did complex life appear? So not just single-cell, animals and plants, and the evidence of life on Earth goes back, let us say, 600 million years or so, not much further than that. So on Earth what happened was that there were single cells, things doing interesting stuff, photosynthesis and things. But from 4, let's say 3 billion years from the origin of life, nothing else, not much going on, slime, the last billion, half a billion-ish, right? Do you see complex life? So on Earth what happened was that there was a single cell, things doing interesting stuff, photosynthesis and things, but from 4, let us say 3 billion years from the origin of life, nothing else, not much going on, slime. So the last billion, half a billion-ish, right? Do you see complex life? So what happened was that there was this thing called the eukaryotic cell, which is what we're made of. And every complex living thing on the planet is made of. Every plant, every blade of grass, and every complex living thing on the planet is made of. Every plant, every blade of grass, every insect, it looks like those things evolved once on this planet. What happened is one type of more primitive cell, a bacteria in this case, got inside another kind of cell called an archaea, got inside and didn't die, and somehow managed to multiply like that. It looks like that's the origin of all complex life on Earth. It looks like that's the origin of all complex life on Earth. So when you see things like that, when you start seeing the things that had to happen to make us, you start to think that this place may be extremely special. And you can make the argument, and I do actually, I think it's very important politically as well, that this could be the only planet in our galaxy currently that has anything on it that can think. If we are the only planet in the Milky Way where brains exist, where conscious thought exists, we are the only place where meaning exists in a galaxy. So if we decide to press the button tomorrow, nuclear war, right? So if we decide to press the button tomorrow, nuclear war, right? We press the button. The person who does that might wipe out meaning in a galaxy. That's an extraordinary thought. And that's why I think that's an extraordinary thought. And that's why I think it's so important. I'm a professor of astrophysics at a university. My research is trying to understand the origins of life in the universe. To help support my channel and gain exclusive access to my podcast and early access to videos, please consider becoming a patron by clicking on the link in the description. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you.